We're going to talk about 12 essential practices for effective continuous delivery. We'll talk a little bit about software life cycles. We'll talk a little bit about the CI and CD, and then we'll eventually get down into the 12, what I call as 12 essential practices we need to have in order to be effective in performing continuous delivery. Way back in time, we used to do waterfall development. And when it comes to waterfall development, this was the industry standard back in time. When I started programming, this was the accepted and expected methodology. And you may wonder, what's wrong with waterfall development? And I would argue there's really nothing wrong with waterfall. The problem really is, when you look at the waterfall cycle, you are going through the phase of analysis and design, and then you are eventually getting down to coding. And when you are doing analysis, when you're doing design, but then when you get down to coding, there is something you can do when you start writing code that you couldn't do before that, which is when you write the code, you can compile it where compilation is needed, and you can run it. And the minute you run a piece of code, you can actually see it executed, and then you can complain about it. And you can start giving feedback when you execute the code. And software exhibits this nature called the observer effect. The minute you observe something, you want to change it. So the problem with waterfall is not that we had these stages of execution. The problem with waterfall is that the feedback really came way late in the game. So if you look at a timeline, and in the timeline, you have taken all this time to do analysis, design, requirements gathering, and you start writing code, and then when you discover what you are doing is not what you want, and you realize you have spent all this time, and you have only that much time left, that moment when you realize that is called a moment of panic. Because you're like, oh my gosh, what do? We don't have enough time to fix this, isn't it? So that is the problem. The problem with waterfall is that the feedback comes way too late. And so we tried different ideas. So we tried to say, maybe that's not a good idea. Maybe we should be iterative and incremental. And here is the amazing aspect of where we are today. When I was a kid, we did waterfall development. Now, today, we live in an amazing world. We do waterfall development, but we call it Agile because it feels a lot better. So if you really look at what companies do, oh, we're doing Agile. And then you're like, so what are you actually doing? Oh, we got a testing team, and we will give that software for them to test it, and they will hack through it manually. Well, imagine this. If you're doing manual testing, how could you ever be agile? Because if you're doing manual testing, you spend all your time testing the software, and then when you finish testing it, even if the developer thinks of changing the code, you got to start testing the whole thing again. Because software is not something you can test in bits and pieces. Because what you make a change in one area can affect something in a completely different area. Software is a nonlinear system. And this we have all seen, isn't it? You have production issues, or you have problems where something is broken. But months later, you're in a party of the geeks, and what do you say? We share these stories, right? Let me show you my scar. Let me show you my scar, right? We all compare notes. And somebody says, oh, I changed the code over here, and we never expected that to fail over there. I often say that the tragedy in production is a comedy during discussion. Because you're like, oh my gosh, this failed so badly, but this is a great topic to talk when we are in a party, right? So we all compare notes, like, let me tell you how mine failed, right? The problem is feedback loops are extremely important. And if you cannot get a really fast feedback loop, then we automatically move towards a waterfall development, whether we like it or not. But anyway, we've tried those things. And to add insult to injury, we have done scrums and sprints. And then we have tried things like Kanban. But the question you want to really ask is, why are we really messing with all of these? And this is one of the things that absolutely fascinates me. If you look at the Agile Manifesto, what are they saying in Agile Manifesto? They're saying that we want to focus on creating working software. I think they missed a word. I would add the word relevant. We want to focus on creating relevant working software. They said we will really focus on the people more than the process. But then you turn around and what happened? We are so tied up on process. Part of the reason for that is we love rituals. And when we are done with rituals, we'll create more rituals. I often mention this one thing I would never forget, the movie on 10 Commandments. I love watching this movie. I've watched it several times. And if you're watching the movie, right in the middle of the movie, they describe a scene where Moses says, hey, I'm hearing the voice on top of the mountain. I need to go check this out. So he wants to go out and he finds the commandment, so he's going to go off. But he's got all these people on the ground. And the sea has parted. They have come to this new land. And what do you do? So he goes to Joshua and says, Joshua, do me a favor. Take care of the people. I'm going to see what's up on the hill. So Moses is gone. So poor Joshua is like, what do I do with all these people? Well, the people kind of get together. They don't have the leader right now. And they are kind of confused. They don't know what to do. And they gather all their jewels. And I love this scene in the movie. I always pause this scene in the movie. And they gather all their jewels. And they dump it. And they create this beautiful idol. If you've seen the movie, you remember this scene probably, right? They create this idol. And then they dance around this idol. And I always pause and say, that's Agile right there. Because we want to really celebrate this, right? We want to really say, forget about all the reality. We just want to chant and be happy. We don't want to be connected to the reality in any way. That is the world now in terms of Agile development. All those things that was written in Agile Manifesto, we forgot about it. Forget it. We want process. And if Scrum is bad, how do you make it worse? So we'll come up with SAFe, because that can make it even worse. Agile is not working. Let's scale what is not working. So that is called SAFe, right? So there is no end to this in terms of what we do. But why not just release the software? Why not release the software anytime a feature is ready? So rather than trying to constrain around this process which is not working, what if we start just releasing software as soon as the software is ready? And I'll be absolutely honest about it. I can talk endlessly about it, but I don't want to give you even the slightest notion somehow that I'm actually perfect. Quite the opposite. I'm not perfect. I'm as flawed as anybody else could be. But in my own experience, I've developed a few different products. I've released those products over time. But I'll tell you, when I started working on products, the hardest part for me was to make that first release, because your mind plays trick on you. You write this software and you're about to release it, and your mind says, no, I think I need to add a few more features. I need to make it better. I don't know what that better is, but it's got to be better. I've got to improve it. And you're holding on to it every day and you don't want to release it. Why? Because in your mind, there's that feeling that this is not good enough to release it. And every single time when that happens, I take a deep breath and I release it. It's as if a burden was taken out of your shoulder. It's out. It's deployed. Others can see it. Others can use it. And all of a sudden, I'm upgrading the software not once or twice, but multiple times per day. I just tweeted this a few weeks ago. I was on a long flight from Europe back to the US. And while I was on the flight, thankfully the technology is so good these days, I was deploying the application multiple times on the flight. I was writing the code, I would deploy it. And suddenly one of my friends said, do you realize you're not deploying your code up to the cloud? You're deploying it down to the cloud, right? And I'm like, yeah, didn't realize that, right? So you can actually do that, because once you get into this practice of continuously deploying code, you remove that burden from your shoulders. You can release it any number of times. And I'm like, oh, I got another improvement I can make. Write the code. Is the test passing? Yes, it does. automate it, move on to working with another thing. So another feature. So why not continuously release the feature? And the real question is, why not? And that's what I want to talk about today. What is it that holds us back from doing it? So continuous integration is not the goal. And a lot of times we get confused. Continuous integration is not the goal. Continuous integration is the prerequisite. On the other hand, continuous delivery is the end goal. But you cannot practice continuous delivery if you don't really have good practices in place. And here is the real important thing to do. If you suck at delivering product, you'll suck more if you deliver it continuously in the wrong way. So it requires discipline. It requires good practices. And if we don't follow good practices, if we don't have the discipline, this is going to fire back at us. It's going to be a disaster. The reputation is going to be damaged. Your bosses are going to be unhappy, and they will tell you this doesn't work. Let's go back to doing Agile. And the point is, we are misguided because we don't address the real problems. We look at the symptoms rather than the cause. Oftentimes, that becomes a problem. So essentially, there are a few steps we want to follow in building it. The first, of course, is you want to build your code. You're going to be writing code. You're going to be compiling it where compilation is necessary, or you're using build tools to package your code, whatever that is. But once you build your code, you want to make sure it's working. So you're going to test it. And again, this is not like you're going to be writing all the code and then come back to test it. Whatever you're doing, you're writing the code, you want to test it. And once you test your code, you want to deploy it to QA and make sure it's working. Again, QA doesn't mean it's a separate department. It's just a separate stage in your process. And what's going to happen? Maybe the QA finds out that the code is not working as it's supposed to, which means you're going to fall back on this phase and you're going to come back to building. Now, what's the difference between testing and deploy to QA? Your testing may be a unit test. Your deploying to your QA may lead you to a much broader set of test cases. You want to make sure the integration test works as well. What good is if your test is passing unit test, but it doesn't pass integration test? You cannot deploy your product. So you want to be sure that it's working in unit test. It also works in QA environment as well. Then you want to be able to automate your deployment. And of course, once you automate your deployment, you are in production. Now, a lot of times we talk about good principles. We talk about good practices. But what we also need to realize from time to time is principles don't live in isolation. So for example, as a programmer, you often talk about the dry principle, right? Anyone remembers what dry is? Sorry, what was it? What was it? He keeps on going, right? Yeah, so we talk about this all the time, right? Thank you. So essentially, but that's not about just code. It's beyond code. So what is really dry? You could say it's the duplication of effort, not just duplication of code. So dry is about duplication of effort. So if you're doing something and putting the effort to do it over and over and over, that's a violation of dry. Because it's not just copying and pasting code. Yes, that is violation of dry, but that's not the only violation of dry. So if you do manual testing, you are violating dry. Because if you're manually testing code, what are you going to do? You got to keep repeating your steps. Every time a programmer changes code, you got to start the testing all over again. That's a violation of dry. So when you think about, oh my gosh, we should follow the dry principle, yeah, we need to really think about this throughout. In a similar way, if you do manual deployment, what's going to happen? If you do manual deployment, you are violating dry again. So essentially, if you're manually deploying the code, what happens? Manual deployment takes, of course, effort, but it is extremely error prone. So when you do manual deployment, somebody physically is going through a series of steps, and then they are deploying the application into production. And to err is human. So you follow the steps, In the middle of following the steps, you get interrupted, or you get confused, or you're forgetful if you're like me, and you miss a step or you misplace a step, and then you put this into production and everything goes up in flames. So one of the very key things is to be able to automate the deployment. Because if you automate the deployment, then you are eliminating these stages that could be error prone. And as a result, you're not only avoiding wasting your time to deploy, you are eliminating the process of errors in the process as well. If you have never done automated deployment, it is enormously difficult to do it. Not because it's actually difficult, it is because it's extremely unfamiliar to what we have done in the past. So it's intimidating. And you tell yourselves, oh my gosh, this is so hard, I don't think I want to do it. But if you really force yourself to be focused on it, fight the battles you have to do, seek the help you can get, and once you automate it, then you have removed that burden from your shoulders. And the time between having to write the code and deploy it shrinks literally. And I can simply say, hey, I commit this code, and if everything is working properly, it shows up in production within minutes. And you're not wasting your time on, and I don't even think of deployment these days. I just focus on writing code, which is what I enjoy doing. And once I write the code, my test pass, and it kind of goes through the stages, and there it appears on the other side, and we can simply use it. So I can bring things to fruition very quickly if I can automate that step. That becomes really, really essential. So the benefits, of course, are the fast time to release. We keep talking about speed. If you want speed, put the effort where you really get the speed. So if you're able to quickly release the product, ask the question, what are the things that delay us from releasing the product? If somebody says, I finished this feature, but you cannot have that released on the other side, I'm honest. I was in Finland, and I was with a group of people, and there was a gentleman who was about 60 years of age. I'm kind of evaluating roughly. A guy who's older than me. And I'm pretty old as well, but he's a little bit older than me. And I was kind of like, and they're in a project which is doing agile development. And I was kind of curious because I see this old dude who's older than me, who's sitting there, and I'm like, I'm curious, I want to ask this person. So I went to him and I said, excuse me, you've been developing software for a long time, I gather. He's like, oh, I've been writing code for 40 plus years. And I said, how does it feel to be developing software today compared to 40 years ago? And he said, are you kidding me? It's a difference between a night and a day. And I didn't expect that to come from him. I thought he's going to be a grumpy old man, get out of my lawn kind of a thing. He's like, this is a difference between a night and a day. I said, really? Why do you say that? And he said, when I was a young developer, I would write code, and I would commit the code, and I wouldn't even know what happened to the code I committed. Nobody would even care. Maybe 9 months, 10 months later, somebody says there's a bug in your code. And I'm like, I don't think that's even my code. I don't even remember it, right? And then he said, today, I feel like what I do actually is relevant. That's the word he used. I feel what I do is relevant. And when I heard that, I almost had tears in my eyes. Because what is your worth? You come to work, you write code all day, and you leave and you say, I don't think anybody cares about this. How do you feel about it when that happens, right? Instead, he said, I feel like there's a purpose for me to come to work. Because I write code, and within hours, somebody asked me something about the code I wrote. I'm like, really? You're integrated it? You're using it? And they say, yeah, we are going to put in production. And I feel like I need to come to work because this is useful. Because people are actually using what I'm creating. That is amazing. Honestly, I did not expect that from him. But I was genuinely so happy I asked the question, and even more super happy that I got that response from him. So you want that faster time to release. What's the benefit of that faster time to release? Is that you can create value and see that it's actually delivering value, it's being used, that is fantastic. It reduces the chances of errors. How so? If your code is integrated often and integrated frequently, you find the errors frequently. If you integrate it less often, it goes up in flames and we don't know where things failed. It actually costs more to fix it. So that's one of the reasons why continuous integration is so important, because we are incrementally. It is rewarding to say, this worked yesterday and we made a change, it still works. Or this worked yesterday, we made a change, it's not working. You got a choice. Roll back, understand what the problem is and fix it, or make the change properly and keep moving forward. So you're able to build on what works and continuously build on what works, and you can keep moving forward. And that is extremely rewarding. There are projects where a code has not been compiled for several days. And you come in and say, I want to make a quick change to the code. And you're like, my gosh, this code won't even compile anymore. How do you feel being on a project where code doesn't even compile? And you're like, you know what? It doesn't matter. It's trash already. It doesn't matter what I do to it, right? It's a very different value system at that point. So it's important to really keep that releasable all the time. It minimizes waste. You're not writing code that is not necessary. It changes your mindset. When you're motivated to see things coming into production, you are saying, let me do stuff that will actually be used because I can see it being used. Do we need to write this code? This is the funny thing, right? When I go to every single team, the question they ask is, oh, we don't have time, what do we do? If you don't have time, do less. That's a simple logic, isn't it? If you don't have time, do less and do what is relevant. So I go to my customers and they tell me, we want you to implement this feature. I always tell them, no problem. I will be glad to implement it. And then I ask them, tell me what I can take out from the requirements for this, iteration so I can implement it. They look at me like, what do you mean take out? I say, if you want me to put this in, I got to take something out. You're not going to get this all fit into this. There's only limited time. Oh, if you're going to take something out, we don't need it. Yes, that's great. Because that was not really high priority. So if you don't give the sense of priority, what will your customers want? Everything. They want everything. Why? Because, hey, software is soft, right? You can keep adding things. Hey, I got one more feature for you. Sure, bring it on. But when you put sense of priority to them, hey, if I have to put this in, I got to take something out. Whoa, wait a minute. We can do it. Or sometimes, yeah, sure. This is really high priority. So let's do this. Let's take that out. But that negotiation has to happen. So we have a sense of urgency, and as a result, we can end up minimizing the waste that may happen. It really gives us the faster and shorter feedback loops. We are able to know what worked yesterday is still working today. There are two kinds of feedback I always want in my system. So what are the two types of feedback? The two types of feedback I want is, the first is one, regression. What worked yesterday still works. This is one of the things I want to know. It worked yesterday, does it still work? And if it is broken, you want to fix it right away. And you want that feedback. Why? Because the time between when you introduce an error and the time you find it, if the time is more, it is more expensive to fix it. If the time is less, it's less expensive to fix it. So as a result, you want to shorten that feedback loop. So that's one, the feedback of regression. The second is relevance. Is this what we really need from the user's point of view? That is the circle of relevance, the feedback of relevance. Is this what I want? Programmers are really good at writing code. But here's one thing I always ask people. Stand at the door. Stand at the door. When somebody is walking in, you just ask them, hey, you're a programmer, right? Yep. If you don't show up to work today, how does it affect the company's revenue? How many programmers will be able to answer that question for you? Because we are eager to come to work to write code, but we should be eager to come to work to produce results, not to write code. Sometimes your answer is, I don't want to write code because I can provide value in another way. So we often don't help people think about relevance. When you come to work, if I ask you, if you don't show up to work today, how does it affect the company? If you say they won't even notice, then I would say turn around and go home, have a good time. Why are you here in this building? Because if you don't contribute to the bottom line and the success of the company, why are you there? So the discussions I have with my business becomes very different. I'm not worried about what feature of Spring can I use. My worry is, what can I do to deliver the value to the customers? And I work my way backwards from that. I don't care about what technology I have to do the work. What do you want me to do? I'll find the technology for it. So it changes the discussion. The relevance is extremely important. So it gives us that shorter feedback loop. And when we get that feedback loop, which is shorter, it allows us to steer the application in the right direction. And it gives us the short time between ideation and utilization. What is the worst thing? When somebody says, I've got an idea. When somebody says, I've got an idea, and if you cannot realize that for 6 months, they even forget they had the idea. So you want to say, if this idea is really useful, let's get this done right away. So this really has a bottom line towards business agility. So business agility is where the business walks to you and says, hey, we really would like to have this feature in production because this has an impact on how we do the business. It has an impact on our customers, our users. How can I get that to you quickly? So that's what you want to really focus on. And you want to shorten the time between when you think you should implement a certain feature to having that feature available in production. And the business benefits a great deal from being that quick. And that's what I mean by business agility. When the business wants you to make a change, how quickly can you get the change to them? And you can deliver the value faster as well. So what I want to talk about here are 12 practices that's going to help us to deliver that CI/CD. So continuous delivery is not going to happen if we don't have a certain amount of maturity. This is one of the things I would say is a problem in our industry. And if you look at the industry, we all learn to write code very quickly. It's not a problem. We learn to say, I want to write code. What do they teach us in school? What do they teach us in the job when we join? Let me tell you how to write code. So we're all eager to learn to write code very quickly, and we do that. But there is one thing that is incredibly difficult if we don't pay attention to actually getting it into ourselves. And that one word is a very important word for us to think. It is called discipline. So discipline is extremely important. If we don't have discipline, what happens? We don't care about the craft. We are worried about getting things done with whatever the objectives are, but we don't have the discipline to do a good job or something that is sustainable. So I would say the number one thing I expect from a good developer is that they have discipline. And discipline is something where you are not infatuated by goals that meet your desires, ignoring the business needs. And this is where discipline is absolutely needed. And sometimes we have discipline. Sometimes we have to learn discipline. This is where we have to ask the question, what are the consequences of my action? If my actions are going to result in bigger trouble later on, I shouldn't do this. I'm not the smartest guy in the world. But my very first job out of the university, when you're a young kid, You take your first job. I don't know about you, but I doubt everything I do. Is this the right thing to do? Is this the smart thing to do? There are people with experience. They do something. And what should I do? And I remember this very clearly. I will not hold this back. I walked into a room where I had a senior developer. This developer has more experience than I did. I had a few months of experience, not even that. This person has years of experience. And I was looking at what this programmer was doing. And I said to myself, I don't understand what they are doing, but I can bet you it's wrong. That's a thought in my mind. And I don't want to be arrogant, but it's a gut feeling you get. This cannot be a sustainable process. Fast forward a few months later, I'm working at the code base. I'm like, I know now it's for sure it's wrong. This is not the way to do it. And what you want to do is to think about the consequences of what we do. Because what happens is it costs more money later on if we don't have that discipline to do the right things. So the first and foremost, create good quality code. It's easy to say good quality code. But why have you, raise your hand if you've seen poor quality code. That's everybody in the room, right? But why is there poor quality? Mention poor quality, it even causes allergies in the room. So, but why do we have poor quality? I'll tell you one thing. Nobody wakes up in the morning out of their bed and say, I'm going to go to work today and write really nasty code today, right? Nobody goes to work saying, I want to write bad code. I hope not. Why do we write bad code? I'll tell you a very simple reason. We don't even realize it's bad code. We haven't developed the sense of what good and bad is. That's one of the problems. But why do I care? Hey, why do you care about good quality code, you may ask? That's a reasonable question. I'll tell you a few different reasons for that. The first reason, you can be agile if your code sucks. As simple as that. You're like, oh, we want to be agile. Good. And you're in a meeting and they're telling you, let's make this change to this XYZ module. And you're thinking, wait, the last time my team touched the XYZ module, we could not go home for the weekend. Hold that thought. We don't want to make that change. Really, why? Well, we have reasons for it. Because, when you all have done this, right? As a kid, I'm sure you have played this because I have. You take a deck of cards. And what do? You put two cards like this, and you put two cards like this, and you put a card as a bridge. You've done that, right? And you build this deck of cards. And it's come up to this point. And everybody in the room is whispering now. And one of your buddies says, hey, let's remove this card from here. And everybody is nervous, right? And then they remove that card, and what happens? The whole damn thing comes down. And those very kids grow up and start writing code. And they say, it's working. I'm going to step away. Nobody touched this. And somebody didn't listen. And the whole damn thing comes crumbling. How can you be agile when you're sitting on a code that is so terrible? Somebody says, let's go make a change. And you look at this and your head is spinning. I don't know what to do. I don't know what to change. I've been on code base where I come in and say, I'm going to make this change. And I start changing this. This one is coupled to that code. Oh, I'm going to change this. That says that won't work. I'm changing it. And suddenly I'm sitting at a piece of code. I don't know how I got here. Has that ever happened to you? And you're thinking, I changed that and that. You're trying to trace your way back. You've just gotten into a maze of change right now. And then in the meantime, your boss is like, are you done yet? He's like, shut up. I don't even know why I'm here changing this piece of code, right? And it's frustrating. And they're like, are you done yet? Done yet what? That's a problem. That's one problem. Here's another reason. Code is how you tell your colleagues how you feel about them. Do you love them or do you hate them? You're looking at a piece of code and you're like, what did I do to you? Why have you written this code like this? Right? You feel that way, right? Because you're looking at this code and it's horrible. You cannot understand this. And the person who wrote it is just walked away. They're like, it worked, but nobody can touch it. That is called write once code. Nobody can read that code anymore, right? So what is quality? You can ask anybody for a definition. Ask them, what is code quality? Ask your colleagues at work. The number of answers you will get is equal to the number of people you ask. I will take almost any answer, except one answer I got from a colleague of mine. And seriously, he said this. This code is great because I wrote it, he said. No, I don't think that's a good definition. Just because you wrote it doesn't make it a good quality code. So here's my definition of what good quality is. I would say the quality of code is inversely proportional to the amount of time and effort it takes to understand it. So the quality of code is inversely proportional to the amount of time and effort it takes to understand it. If the code is of really good quality, you take less time and effort to understand it. If the code is of poor quality, you'll take more time and effort to understand it. So, after all, if we talk about speed of development, you want good quality code. Because good quality code reduces the time you need to spend on it. A poor quality code increases the time you're going to spend on it. So these are the reasons why quality matters. So if you want to do continuous delivery, the number one thing we need to start is the quality of code. That starts in everything that you have to work with. In every angle. How many times have you seen this? You look at a variable name like A, B, C, X, Y, Z, P, Q, R. Ever seen that one? No? Single letter variables for everything? Would you do this? Would you name your kid P? Right? Child, what's your name? P? Is that your initial? No, that's my full name. The only way it can happen is when both the parents are programmers. Right? If one parent is a programmer, the other one is not, like they're a civilian. When you say, I want to name the kid P, you're like, are you out of your mind? The kid is saved, right? Gets good name. But otherwise, when we give names to variables like this, it becomes abstract. Names represent abstraction. If we give a wrong name, we don't understand what it means. That wastes time. Similarly, writing long functions. Writing code where we cannot understand what any function is doing. So the problem is in our industry is this. Knowing is not doing. That's the problem in our field. Knowing, right? This is a consistent theme I've seen. Knowing is not doing. Let me ask you a question. Raise your hand. If you think writing long functions is a good idea, we got to go write more long functions. Nobody wants to raise the hand. He's scratching his head, doesn't count. So no. Let me ask you a completely different question. At work, have you seen long functions? The hands go up, isn't it? This is called a cognitive dissonance. I've got good news and bad news for you. You didn't do it because you just told me a minute ago you don't believe in writing long functions. That's a good news. The bad news is the people who write long functions are at work right now, making those functions longer as we speak. There is no end to it, right? Knowing is not doing. You know not to write long functions. Hey, where did the long functions come from? So we know these principles, we know these practices. There's a disconnect from knowing those to doing those. And that's something we need to work hard in our industry. This is why I care about code reviews. This is why I care about collaborative development. I'm not going to be perfect. I'll be honest about it. I will be open about it. I write terrible code. I will not even pretend to you. If you ever look at my source code, you're going to say, oh my gosh, Venkat, you give all these wonderful talks. That's how you write code? But here's what I learned, honestly. I write really terrible code. But I'm extremely good at finding fault with other people's code. So I realized, rather than pretending, I'll write the code I write, I'll give it to you, you review my code, I will review his code, and we both have better code at the end of the day. So I don't want to pretend that I can be perfect. To err is human. But collectively we can make it better. So this is why quality code is important, but you cannot just achieve quality by chanting, we do good principles. Sorry, there's a disconnect. Good principles are in our mind. It doesn't flow to our fingers oftentimes. So this is why I do reviews, I collaborate, and then I make the code better. So essentially, that's the very first thing I would say. Create good quality code. If you create good quality code, it gives you the pathway to creating code that is maintainable. It improves the chance of releasing faster. Write automated test, unit test, acceptances, functional test, integration test, contract test, whatever that could be. But write automated test. Automation test is really hard when we have never done it before. But I remember writing code and saying, I don't need these stinking tests. I write good code. And I remember, honestly, the very, very, very first time I seriously sat down and said, I'm going to do test-driven development. And that was in 2003. I had been developing software for more years before that time. But I was the cowboy coding. I wrote code. It works. I don't care. And 2003 is when I wrote my very first unit test seriously for production code. Until then, I knew what it is, but that's not for me. I'm beyond that. But that's the first day I did that, and I saw the benefit of it in action and reality. And I was convinced. And this is one thing I tell people. You know, I often say, who is a programmer? This is the best profession in the world, by the way. Just don't tell this to anybody outside this room. There's a secret between us. Promise? Okay. Programmer is the one who gets hired to write terrible code and gets paid more to come fix it. This is why we are in the best profession in the world. In no other profession this happens. You suck. Take more money from me. That never happens. Plumber, you came to my house yesterday, you broke the pipe, the water has flooded. Please come back, I give you more money. Do you ever do that? Programmer, you wrote the code last time, it doesn't work, come fix it, here's more money for you. This is luxury, right? No other profession has this luxury. We get paid to really do bad job, and we get paid more to come and do even more bad job. We can keep going further, right? So when I used to work for companies, it was easy. Because I can write code, I can walk away. It's somebody else's problem. How much money did you lose? None. I only take money. Once I found my own company, it was completely upside down. I'm here talking to you. Amazing, I'm happy. But I got code in production. If it doesn't work, what's going to happen? Two things can happen, right? If it doesn't work, guess who spends time awake in the night tonight to fix the code that is supposed to work? I would rather sleep tonight than fix the stinking code I wrote. Or I can hire somebody and say, take my money. For what? So you can fix the mess I created and create your own mess. So this is the lesson I learned. And the lesson I learned is this. I write automated tests, not because I have a lot of time. It is because I don't. As simple as this. So this was my lesson back then. that I learned, and I said, oh my gosh, my time is valuable. When my time is valuable, how do I protect that time? If I write automated test, I am not sitting there manually wasting time knowing whether the code is working or not. When I wrote the Practice of an Agile Developer book, Dave Thomas was my editor, the Pragmatic Programmer. He called me and said, Venkat, you say something here that's intriguing. And he read what I had written. I said, unit test or automated tests are angels on my shoulder. That's what I wrote. He said, that's a metaphor I've not seen before, he said. And I said, yeah, automated tests are angels on my shoulder. Why? Because they whisper in my ears. They say, hey, Venkat, don't even bother committing this code. It doesn't work. I would much rather my automated tests tell me my code sucks than my coworkers and customers tell me my code sucks. It makes me look like a better programmer than I am. And that's the reason I want to write automated tests, and I do. Because it saves me time, not because I spend more time, not because I have more time. So this is the second discipline that is absolutely necessary. Write automated test. If your team has no culture of writing automated test, and if you say, we want to go to continuous delivery, that is not going to be a continuous delivery. That's going to be a continuous disaster. It's going to go up in flames every time you put that in production. And your customers are going to call you and say, dude, this worked yesterday, it's not working today, what's up with it? And that's not going to help you with your reputation. So automated test is the second most important thing. You say, we don't have a culture of writing automated test. What should we do? I'm not being offensive when I say it. Grow up. Here's why I say grow up. You go to this amusement park and you say, I want to go on that ride. And we all hated this, right? What do they say? Come over here. And they have this line. Stand. Kids are like always angry. And they come and stand. And they're like, oh, you're that short of the line. Sorry, you got to grow up before you can take this ride. That's the growing up. If you want to do continuous delivery, you got to be that tall. And how do you get that tall? You got to develop these practices. Otherwise, you're going to end up on the ride and things are not going to end up really, really well. They're not telling you don't go on the ride because they want to hurt you. It's quite the opposite. It's not going to end up well if you go on the ride when you don't have the height. Automated testing is one of those. You want to make sure that you have that. In that note, use fakes for end-to-end integration testing. If you're doing integration testing, you want to know your code is working not in isolation alone, but it's working integrated as well. But here's the problem. My code is talking to your service. So you call into my code in the test, my code and calls your code makes a change. You run my test again, I send a request to you, you reject. Sorry, this data already exists. What do I do now? How do I integration test my code when it depends on your code? If you provide a fake service that represents the exact contract as the real service, but your fake service is going to fake response, then I can do my integration test with your fake service. It verifies the contract at this point. So as a result, it can give me confidence, A, that my code is working. B, you change the contract, I get an immediate feedback that my code will no longer work because the interaction contract is broken. So fakes become very essential for this purpose. That again requires discipline, time, and effort. All artifacts should be under version control. This is a discipline. And maybe you will say, hey, Venkat, this is 2024. We used Git. Well, great. All your code is in Git, correct? Or any other version control, I don't care what it is. All your tests are in Git, isn't it? We hear S and some people are like, what a concept. All your requirement documents are in Git, isn't it? Why not? That's an artifact too. Why is it not in Git? Oh, that's somewhere. Where is it? Is it version controlled? How do you know what the change is? It is cheap to version it, and yet we don't do it. Why? Because we keep it away. But all artifacts, if you don't like the talk, you can just tell me. Okay. All artifacts should be under version control, right? That includes code, test scripts, design documents, requirements documents. Any artifact has to be in version control. So you can trace back into it. You can reason. You can keep track of where the changes have been. And they're not in version control. Why? Because nobody bothered. Honestly, maybe we didn't even think of it until that's mentioned, right? You're like, yeah, why not? So maybe that's what we should think about. Maintain and merge often into integration branch. Avoid long-running branches. I follow one rule in my life. When it comes to merge help, you should always give it, never receive it. This is just one rule I follow, right? You never want to receive merge help. You always give it. It's very easy to give it. Merge frequently and let them suffer. So seriously though, think about this for a minute. This is fundamental, but yet we don't realize it. I'll ask you an honest question, right? This is not to put you down, but an honest question. Have you ever done the following? Raise your hand if you have. You opened a few files. They're all in version control. You made the change, made the change, made the change. I like this change so far. And then you make a few more changes, and then you're like, I don't like this change. Undo. Oh yes, I opened that file, I changed it, I saved it. Let me open that file, let me undo it. Now you have spent 10 minutes undoing. Ever happened? We all have done it, right? Absolutely, me including. The first time you do it, the second time you do it, you say, there's got to be a better way to do it. So here is the one rule I follow. The cost of undo should be 0. The cost of undo should be 0. Why? The reason is innovation is high when we waste less time to roll back. Because our human mind is amazingly capable. You think of these bright ideas. Ooh, let's try this. Hey, it works. Commit. Ooh, let me try this. That's not as smart as I thought it is. What should I do? Rebase. Throw away your change in one shot. Revert back to the previous version and off you go. The cost of undo is 0. What happens if the cost of undo is 0? You don't hold back. You don't worry about making changes. You're like, let me try this idea. It works, keep it. Let me try this idea. It doesn't work, throw it away, rebase. So you want to really be committing very frequently so that you reduce the cost of undo to 0. Then you're able to innovate much better because you can move faster by having frequent commits. So when I use git, commit, rebase, commit, rebase, commit, looks like this is good. Push. When I do a push, I can merge these commits and push it. I have the safety to roll back when I need to. But I push it when I want to have others see it. And what is that? Discipline. It's discipline. I'll tell you one story. It would be funny if it's not true. I was in London. I had worked the entire day with the developer. It was 6:30 in the evening, which is really late for folks in London, at least for the people I know. So it's 6:30, and Mike is sitting there. The boss comes over. Hey, folks, you've been working long. Are we wrapping up for the day? Yeah, we're done. So how was the day? He said. And I said, oh, the day was great. We accomplished all these things. But there's only one thing I'm not happy with. He said, wow, what are you not happy with? And I said, we spent this entire day writing code and we never committed the code. And the minute I said that, Mike said, whoa, hang on, Venkat. We got process in my company. We will not commit code until we go through a process. I said, Mike, if you commit the code, nobody will die tonight. I promise you that. The only benefit is you got the code safe. Oh, no, we got a process. And the boss said, Venkat, why don't you back off a little bit? If Mike doesn't want to commit, Mike doesn't commit. No problem. That's the beauty of being a consultant. You can walk away without guilt because next week it's not your problem. So the next day I come back and I'm sitting with another team and they said, how do you do this stuff? I said, you know what? I can talk about it, but I just spent time doing this with Mike yesterday. Oh, we don't want to waste your time. And as he's saying, he picks the phone. Hey, Mike, come over here. Mike comes over. Hey, you guys worked on this yesterday, right? We want to just take a look at it. He says, well, I've got a good news and bad news. I'm like, my face is red. And you don't want to say bad things to your customers, clients. I'm looking on the floor. He's like, what's the bad news? Well, Venkat said we had to commit it. I said I won't. But I came this morning and by accident I deleted the whole directory. It's gone from the face of earth. And then he looks at me and says, can I schedule time with you for tomorrow? I'm like, yeah, pay me twice. And the next day I had no ill intention. I'll be honest about it. No ill intention. We wrote our first test and we wrote the code. My question to Mike was the following. Mike, the first test is working. What's the next test we should write? But I phrased it wrongly. I said, Mike, the first test is working. What should we do now? His immediate response, commit. I'm like, it's up to you. No, that's the right thing to do. What about your process? He's like, don't worry about the process. Well, sometimes we take more effort to learn what the right things are. So the cost of undo should be zero, commit frequently. All environments, development, staging, production, everything should be alike. The more the differences are, the more it hurts you. So keep it consistent. When you are automate changes to your database schema. This is one thing that costs a lot. DB deploy, Liquibase. I use migrations when I program in Ruby on Rails. There are technology available to push changes to your databases so that you don't have to do manually. All the way from testing all the way down to production. By automating change to the database, you relieved yourselves of that burden. So find the tools that will automate that deployment all the way to making changes to the database schema. Practice continuous integration, compiling, running the test, checking the styles of the code, checking code complexity. I use tools that fail my build if my code is more complex than it should be. And as a result, you can keep an eye on code complexity continuously by using automated tools. And build and verify the stages. So there's a commit stage, there's an acceptance testing stage, a manual testing stage. There are certain things that may have to be tested manually, small portions, performance test, and release stage. And build these stages. When one stage clears, you go to the next stage. If a stage fails, you go back to the previous stage. And then you rework your phase through it. Create automated deployment scripts. The infrastructure as code. I cannot emphasize that enough. If you ask me, Venkat, what did you do during Thanksgiving? I'll tell you proudly, oh, I was in Greece. You're like, oh my gosh, you spent Thanksgiving weekend in Greece. How was it? I was in the hotel for 48 hours, writing deployment code, kicking and screaming, and ordering food in the hotel so I can eat and continue to code. That was my weekend. Away from home, trying to get a deployment working. And if you ask me, was that worth it? Every minute of it. That was in November. Between November and now, I've pushed my code thousands of times on my production system. That automation scripts I wrote is saving me every day. Because I just commit, My test fail, I fix it. My test pass, it goes to production. I don't have to do manually. That phase is hard if you have not done it before, or it's hard when you have done it before, but this is a different environment. You got to take care of the provisioning. You got to take care of every single security detail. You got to really meticulously plan for it. It was a journey I had to take. It was hard, but I'm so glad I did it. So make sure to write automated scripts for deployment. That is absolutely essential. Create a release strategy. This is something I follow very thoroughly. Rule number 1 that you need to follow, the one I follow, do not, this is something I do, do not recycle a production instance. This is a terrible idea. Do not do this. What happens if you recycle a production instance? Your instance is up and running, you apply a patch to it, and you say recycle, it goes down, it doesn't come up. That moment is called panic. Hey, the system is down. I know. It doesn't help you telling me that. I brought it down. And now everybody is lined up. Do you know that it's broken? Yes. I'm not having a great time. I'm trying to find out why it's broken. This is self-inflicted wound. Never kill a system in production. That's a terrible idea. The system is working. What do? Don't touch it. Spin up a new instance. Oh, that's not working. Kill it. What did you lose? No damage on availability. What is available before is available now. Spin up a new instance. Oh, that seems to be okay. Send some traffic to it. How does it behave? Seems to be holding up. Good. Now kill the old instance. Let that become your new instance to continue. You are always keeping things available. This is a very important thing to remember, right? Oh, I can just go on that machine, make a change and push it. Please don't. That's how we get into mess. Next thing you know, 7 hours of your life is gone. And there are 200 people waiting on you, asking why things are not working. Little thing. Spin up a new instance, kill the old one when everything is stable, right? Just minimum things like that to think about. So immutable updates. Once something is up and running, it's immutable. Don't change it. Blue-green deployments. You have 2 versions going. If the new one is doing great, kill the old one. If the new one is not doing good, keep the old one. You can also do canary deployments. You send traffic, small amount of traffic to certain systems, measure its performance, behavior, correctness. If it's working really well, spin more instances of that nature, and then kill the old ones. So there are strategies that we can use, and of course monitor applications in production. If you don't monitor it, how do you know how your deployment really went? So this requires availability. If you ask me now at this instance, if you say, hey Venkat, how many of your instances are running? I can tell you that in a second. You can ask me, what's the throughput of your system? I can tell you that right away. I know exactly what my instances are taking time, how much time they're taking, because I got tools that monitor my system in production. And I want to keep an eye on it. If things are degrading, I need to know it right away and I can make changes to it. That becomes very important. So to summarize what we talked about, if you want to go into CI/CD, you need to have discipline. You need to have a certain set of practices that will help you to get there. Continuous integration is a prerequisite for continuous deployment. Continuous deployment is highly rewarding. I've got applications in continuous deployment, but the journey to it was not easy. It required following every single one of those steps. They are hard if we are not familiar with it, but every bit of it is worth. And you don't have to do it alone. You can look for help, you can look for support. But if you finish that, then you can reap the benefit of it. Hope that was useful. Thank you so much for your time.